In this session, Neil Madden discusses the geometric proportions of the foot and the trimming process.
Welcome to Scientific Horseshoeing, Hoof Capsule Geometry, a guide to maintaining equine soundness. The theory. It is proposed that maintenance of the hoof capsule geometric proportions has a profound effect on hoof-related pathologies that can result in equine lameness. This geometry is in relation to equitable anatomical landmarks as proposed by Professor William Russell, 1901, and David Duckett FWCF, 1991. The diagram from the photograph represents the solar surface of the hoof capsule, and imposed upon it is a number of lines of geometric proportion joining and aligning some anatomical structures within the foot that are important to identify whilst dressing feet to achieve geometric proportion of the hoof capsule. First of all, the line through the center divides the foot into two equal halves, and they should mirror each other. Secondly, a line horizontal to that center line divides the foot from front to back in half. This also corresponds with the center of rotation, which will be described later in our lecture. There's also a second line that's about 5 millimeters behind the point of frog, which represents our point of pressure or zero point of moment, but we'll use the term point of pressure. Two lines are drawn from another anatomical structure we need to identify. It's the buttocks of the heel at the widest part of the frog. We need to identify them, and the pillars opposite the buttocks of the heels. The other anatomical mark that we need to know, we need to identify, is the true point of frog, which melds with the sole. This structure here is maintained and never moves in the hoof capsule. The other anatomical structure is the inside border of the white line. So we need to identify the heel buttresses as the widest part of the frog, the true point of frog where it melds with the sole, the inside border of the white line, and the pillars. Again, we can see a diagram of the geometric proportion foot map relating to the solar surface of a hoof capsule, identifying heel buttresses, true point of frog, pillars, and the inside border of the white line. To understand the point of force, the point of force is a line projected down from the extensor process of P3 and is adjacent to the insertion points of common digital extensor tendon and the deep digital flexor tendon. So this is represented by this line, dropped down from the pyramidal process of P3 adjacent to the attachment of the common digital extensor tendon, vertically through the foot, and you can see there is the insertion of the deep digital flexor tendon. The point at which it comes out on the solar surface is represented by line 1, which is approximately 5 millimeters behind the true point of frog. So that's our point of force. The center of rotation is a line drawn down from the center of the rotation of the distal interphalangeal joint, and this is line 2. So the lines taken from the center, the motion of the pedal bone as it rotates around the articular plane, this is the center of the distal interphalangeal joint. A line dropped horizontally through and down through the foot will represent the center of rotation by this line on the bottom of the foot. So this is how we identify point of force and center of rotation. And to mark them on the foot on our anatomical landmarks, the point of force is approximately 5 millimeters behind the true point of fog once we've exfoliated the sole and we've found it. And the center of rotation is in a line with the widest part of the foot. These measurements can help us to evaluate the horse's foot pre-trim. On the solar view, a line is drawn across the widest point of the quarters. This equates to the center of rotation. You can see that the widest part on this foot is around here, so there's our center of rotation. A further line is drawn approximately 5 millimeters back from the true point of frog. This equates to the zero moment or the point of pressure, which is here. You need to exfoliate the sole to find the true point of frog so that you can gauge 5 millimeters back. Remember that these are guidelines and not a rule, so it's a guide as to where these structures are. The distance between these points dictates the position of the quarters. So now that we've exfoliated the sole and we've imposed a line down through the center of the foot, we've identified the widest point of frog and the buttress of the heels. Two lines are projected forward from the buttress of the heels to the toe pillars. And a line is projected through the center of the foot. So we've projected the line through the foot and we've joined the two pillars up with our heels, that's the yellow lines. Then if we join two diagonal lines that are projected from the heel buttresses to the opposite toe pillars, these should intersect at the center of rotation. So once we've identified the heel buttresses and we've drawn a line down to link them up with the pillars, if we make further two lines so that they cross, where they meet in the center will be the center of rotation. And that should be in line, roughly in line with, that will be roughly in line with the widest part of the foot. Also notice that we put in here the center of pressure, 5 millimeters back from the true point of frog. And what this allows us to do is to assess the proportions of the foot. When we look at it like this, we can assess this radius of the foot with this radius at the toe, the radius of the quarters on either side, and the radius of the heel quarters. So it allows us to assess in geometric proportion to each other different aspects of the foot. So we can assess the left side with the right side through the center. We can assess the radius of each part of the toe and quarters with the opposite toe quarter so that we get a symmetrical structure when we're dressing the foot. A line projected from the two toe pillars across the toes shows the optimum point of breakover. This is our grey line here, so there's the optimum point of breakover. The distance between the point of zero moment, or point of pressure, and the last weight-bearing point of the heels should be the same as the distance from the toe to the center of rotation. And what this means is that if we were to measure from the toe at the pillars to the center of rotation, that distance there, and we were to equate that to our center of pressure to the heel buttress, those should be geometrically proportionate in distance to each other. The height of the toe should equate to the distance between the point zero moment, point of pressure, and the last weight-bearing point of the heel, also the distance between the center of rotation and the toe. And what this means is that if we look at the distance or the measurement we took from the point of pressure to the heel, and we equate that to the center of rotation to the toe pillars, those distances, that one and that one, should be the same as each other, and they should also equate to the distance from the toe up to the coronary band, which represents the length of the dorsal wall. The ratio here should be approximately 1 at the heel to 3 units at the toe. And that tells us that the hoof capsule is in geometric proportion, one aspect proportionate to the other. So now that we've got an understanding, a basic understanding of geometric proportion, we can apply that to the trim. And there are a number of things that we've got to do before we can put our map onto the foot. And it's a skill that you need to develop. To begin with, you need to draw the map on the foot as a guide so that you can compare the different radii of the foot at the toe and the quarters and the heels, and the center of the foot, identifying the heel buttresses and the pillars. So you can draw it on with a ruler and a black marker. As you become more experienced and you progress, you can impose these lines of proportion onto the foot from your mind so that you can see exactly where you're going. That comes with experience. So to begin with, you need to start to draw the map onto the foot. Assessing the foot. The foot is assessed from the farrier's view down the long axis, judging the height of the heels and the solar plane. All excessive or exuberant perioplic horn must be removed from the heel bulbs to get an accurate assessment. So when we're going to dress the foot, we need to be able to see the plane of the foot clearly when looking down the long axis. What we're looking for is the plane of the foot should be perpendicular to the long axis at 90 degrees. So we need to make sure that we trim the frog out so that we can see the heel buttress, and we clear the perioplic horn so that we can assess the height of the heel, and we can assess where the heel should be in relation to the widest part of the frog when we remove excess heel height. So that's the first assessment we make with the trim. So we're looking at the heel height, we're identifying the heel buttress, making sure that we've trimmed the frog up and we've cleared the periopal. The loose horn around the white line, solar junction, should be carefully removed with the draw knife. This will expose the white zone and solar interface. So you're going to exfoliate the sole around the white line area. You then take your knife, a loop knife, in an upright position. It should be taken and run around very carefully the white line to find the true depth of the sole. And that means from the heel, you exfoliate the sole all the way around so that you find the junction between the sole and the white line of the wall, and you can find the depth of the sole in this area. This allows you to assess how much you can reduce the foot in height and how much you can come back and dress the foot back. The frog should be trimmed so it's normal proportion and to accommodate hygiene. Not forgetting we need to identify the true point of frog. The unexfoliated sole should carefully be removed with the hoof knife and the dorsal wall reduced, if necessary, with the rasp. The foot should be taken and checked for level. So if you haven't drawn in your geometric proportion in the box, what you're looking for is the relationship between the heel buttress and the toe pillars. So the box is there. We then join the box up through the center to find our center of rotation. And we're also assessing the foot one half against the other for symmetry. You would then, using your rasp, reduce the excess horn, removing any flares and making sure that the thickness of the wall is uniform from heel to heel in relation to the shape of the white line. We make sure that it's symmetrical through the center and that we get a good heel platform by finding the buttress at the widest part of the frog. Remember that if you draw your lines on, you'll be able to assess the radii at the toe on either side, the radius of the toe quarters, and the radius of the heel quarters to ensure you get a symmetrical platform through the center. You can then view the platform through the long axis for level. The height of the wall should be reduced to create a level bearing border with the heels adjacent to the back of the frogs and central sulci. So once we've assessed with our geometric proportion of the box where the heel height should be, you can then reduce that with a rasp. The other aspect of making sure that the sole or the bearing surface of the wall is flat is that it wants to be level, perpendicular to the long axis from heel to heel through the toe. You're looking to make sure that the bearing surface isn't undulating up and down, and that it isn't sloping either inwards or outwards, that it's actually flat in line with the perpendicular axis of the long axis. Once we've achieved our foot and dressed it back from underneath, you can then take the foot forward onto a foot stand, and the foot should be taken forward, and any flares dressed, making sure any distortion of the wall due to compression is taken into account. So if you notice on this picture, you'll see that the foot's being dressed and it's left a facet. So our template is related to this part of the facet underneath. So the shape of the foot and the amount the wall needed dressing back in relation to the flares is represented by this inside line here. So we then need to take off or dress back the flares from this point to about 1/3 of a way up the wall, so that we create an even platform through the center. And you can assess this by imagining a line through the center of the limb and dorsal wall. And you take your rasp and not overdressing it, you make sure that you dress the foot back no further than the template that you've made from underneath the foot. So in this case, what we've done, the foot was marked pre-trim, and it can be seen there is a discrepancy between the heels to the center and the toe to the center, showing unequal load-bearing platform. So when we put our geometric proportion, we've imposed it and drawn it on the foot, we can see that the heel platform relationship to the toe platform is disproportionate. Once geometric proportion has been applied and the foot has been dressed in the manner that we've just explained, it's possible to see that this foot being marked pre-trim can be seen there is a discrepancy between the heel to the center and the toe to the center, showing an unequal load-bearing platform. That post-trim, it can be seen that there is a more equal weight-bearing platform. So geometric proportion of the application of an accurate trimming in relation to our grid or graticle or box that's imposed on the foot will result in an even more weight-bearing structure, which is important mechanically. So you can see that this foot's being marked up. A measurement taken of the toe height, and this is compared to the center of rotation, is then compared to the measurements from the point of force to the point of heel. So what this is we're talking about here is that the distance from the pillar to the center of rotation should be equal to the distance from the bulb of heel to the heel buttress to the center of pressure. And that's what this is creating. So this distance here is equal to this distance here, so that we're checking that the foot is proportionate from front to back. A line through the center, so you can assess that it's proportionate from side to side, and that it is symmetrical in shape and relates each radii, this radii on the toe and this radii on the opposite toe, are of equal diameter and radius. This radius from toe quarter is equal to this radius on this side. So a shoe is made or chosen to match the dimensions of the trim foot. The dimensions are described in the first part of this presentation. So the shoe, when we make it on the anvil, we make it in relation to the box that we have imposed on the foot, exactly the same. The shoe should be symmetrical through the center. It should be equidistant through the widest part at the quarters. If we were to join the heel to the pillars, which is where the first nail hole is, and we join those two lines with a cross, that will equal the center of rotation. If we impose the center of rotation with the shoe on the center of rotation of the foot, you get one imposed on the other. And here's the finished job. As described, we've dressed the foot through geometric proportion, identifying the anatomical structures, the heel buttresses, the true point of frog, the pillars, and the inside border of the white line. We've then dressed the foot back and made sure it's proportionate from side to side and from front to back. We've drawn lines from the heel buttresses through to the pillars. We've joined them up, and then we've joined the heel pillars to the heel buttresses from corner to corner, which identifies our center of rotation. When the shoe's been made, the widest part of the shoe has been at the center of rotation because the shoe's made on the same principle. The line between the pillars represent the optimum point of breakover. Notice again, we can assess the radii of the shoe. This radius equals this radius, and the template we put it on, these radii should equal the radii of the foot. The toe quarter radiuses are equal to each other through the center. The heel and quarter radiuses are the same as each other, once again through the center. When we use our method of assessing proportion, if we measure from the pillars to the center of rotation, that should equal the distance from the heel to the center of pressure. These distances should also relate to wall height from the toe, the wall length, to the top of the coronary band. If all these proportions relate, then the shoe should complement the foot dressing and be fitted to the prescribed protocols, allowing for the normal physiological of the foot. This will give you an idea that the foot is geometrically proportionate, maintaining soundness. Shoe choice is based on the conformation of the horse and the pathology of the foot. What do you mechanically want to achieve is the first question you need to be asking. Whatever the shoe choice, the foot dressing protocol must follow the prescribed techniques of any value. So even when you're dealing with distorted feet and with pathologies, it is possible to impose geometric proportion ideology onto the foot in the form of the grid, so that it will allow you to assess which parts of the foot require extra and which parts of the foot require less in relationship to shoe pattern choice, to make sure that you achieve optimum function within the foot. If geometry and symmetry cannot be achieved through foot dressing, the shoe can be used as a weight-bearing platform. Lifts can be utilized to achieve level footfall. These will be proportionate to the amount of displacement of the compressed horn, so that the complementing bits of the foot that are dysfunctional or not there, that should be, by the use of increasing platform surface areas and reducing ground pressure, increasing and stabilizing the foot with more caudal support, achieving greater bearing surface to reduce ground pressure. All these aspects of the mechanics of shoes will help to complement aspects of mechanics that are dysfunctional. So I hope that's clear enough for you. I'd like to thank those underwritten. Thank you for watching Scientific Horseshoeing.